Today I'm going to talk about LeetCode question 875, Koko eating bananas. Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. So like the 0th pile has 3 bananas, first pile has 6 bananas, etc. The guards have gone and will come back in 8 hours. Koko can decide her bananas per hour eating speed of k. Okay, so like k bananas per hour. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So if we have she eats 4 bananas per hour and she only eats 3 this hour and just waits till next hour to eat the rest. Koko likes to eat slowly, but still wants to finish eating all the bananas before the guards return. Return the minimum integer k so that she can eat all the bananas within 8 hours. Okay, so find the slowest speed, bananas per hour, find the lowest speed where she can eat all the bananas within this time frame. Okay, she wants to eat slowly. Okay, so we can look at an example here. So for this example, Koko can eat 30 bananas an hour, and the guards will be gone for 5 hours, so she has 5 hours to eat these bananas at 30 bananas an hour. So like here, she eats all of them. Here, she eats all of them. Waits next hour, eats all of them. Waits next hour, eats all of them. Waits the next hour and eats the last batch. So that equals 1, 2, 3, 4, 5 hours. Okay. So you can kind of see here an easy way to determine one way of determining a k value, an option for k, is to get a large number. Say any large number, like 100. Like she could eat 100 bananas per hour, and she could reasonably eat all these bananas. So look at the first example here, within 4 hours. But we want the minimum integer k, okay? So what's better than 100, a million, 1,000? Well, the next best thing, or even infinity, the next best thing is to get the largest element in this array here. Okay, so if you get the largest pile of bananas, she can eat those number of bananas per second. So if you have 11, she can reasonably eat 11 bananas per hour and finish in 4 hours. But she wants to eat slowly, so we want, if possible, we want to find eating speed below 11. And how can we find that? Well, starting from, say, 11 here, okay, what we can do is decrement 11 and check for, can she eat all these bananas within 10 hours? Or can she, at a speed of k 10 bananas per hour, can she eat all these bananas within 8 hours? Okay, so for here, she can eat all of this pile 1 hour, all of this pile 1 hour, all of this pile 1 hour, and for this pile she can eat them in 2 hours. Okay, because she eats 10 bananas 1 hour, and then the next hour eats 1, so 2, 3, 4, 5. She can eat all of them in 5 hours. Is there a smaller number other than 10? Well, we can check 9. Okay, she can eat all of these, all of these, all of these, and she eats these bananas in 2 hours, so again we get to 5. She can eat them, so she can eat them in 5 hours. But it's gonna take a while to check all these decrements by 1, okay? Like 9, 8, 7, etc. Is there a faster way? Yeah, and there is, using binary search. So between the range of 1 and we have the max value of the array, 11, where 1 is where it eats 1 banana an hour. Is there a number between this range where she can eat the slowest within 8 hours? Okay, and we can find that through binary search. So how can we do that? So we take, say, the lower range and the upper range. Like we have find the median. Let's check 6. Can she eat at a rate of 6 bananas per hour within 8 hours? Okay, she can eat 1, okay, pile in 1 hour, this pile in 1 hour, this pile in 2 hours, and this pile in 2 hours. So 2, 4, 6. Okay, great. So that's a possible answer, but can we get even smaller? We can certainly try. So within the range 1 to 6, is there a value where, is there a rate where she can eat even slower within 8 hours? So we can do 7 over 2 equals 3 if we're flooring it. So yeah, let's check the value of rate eating speed of 3. Okay, so she can eat this pile in 1 hour, this pile in 2 hours, this pile in 3 hours, okay, and this pile in 4 hours, because 11% 3 equals 2, okay. Well, let me check that math real quick. Yeah, she can eat them within 4 hours. Okay. So 4, 5, 6, 7, 8, 9, 10. So it'll take 10 hours to eat all these bananas with a eating speed of 3, but she only has 8. So let's check the range 4 to 6 now. Okay. Now, within the range 4 to 6, the median is 10 over 2 equals 5. Can she eat the bananas at a rate of 5 per hour? Let's check. Okay, so she eats this in 1 hour, and this in 2 hours, this in 2 hours, this in 3 hours. So 3, 4, 5, 6, 7, 8. Okay, great. This is a possible answer. Can we get even smaller between the ranges of 4 and 4? Where 8 over 2 equals 4. Oh, sorry, this should be probably a 5 here. But anyway, 5, 6. Is it still the same? What about 4 bananas per hour? Let's check. So she can eat this in 1 hour, and this in 2 hours, this in 2 hours, this in 3 hours. Okay, so 3, 4, 5, 6, 7, 8. Great, this is a possible answer. And there's no other ranges we can explore, so this is the answer here. And that's how we're going to go about it. And the runtime of this is O of n times log m, okay? Where log m, where this guy, why is this? Well, first of all, we're doing a binary search here, where m is the largest number in array, okay? And why n? Well, while we're checking this binary search, we need an inner loop with the non-binary search where we calculate the number of hours by iterating through this array here. So, and this represents length of array. So we'll need an inner loop there to check if we can eat them within the specified hour range. And that's the runtime.